Temperature can also affect the rate of a reaction. Temperature is defined as the measure of the average kinetic energy of the molecules in a sample. So this graph shows a distribution. It's called a Maxwell-Boltzmann distribution, and it shows the distribution of kinetic energies at any given temperature. So each curve, like in red, you can see the red curve is minus 100 degrees. The green curve is 20 degrees, and the blue is 600, okay? And so you can see there's a wide distribution of the average kinetic energy, the number of molecules that have an average kinetic energy at a given temperature, okay? And so as the temperature increases, the curve of the distribution flattens and broadens, right? So you can see as we go from minus 100 to 600, we have a much flatter, broader distribution of molecules. So at higher temperatures, a larger population of molecules has a higher energy. And so do you see this dotted line for this activation energy? At the higher temperature of 600, look at the amount of molecules that have a kinetic energy above that activation energy versus look here at the minus 100. Look at how few molecules have that higher energy. So higher energy generates greater velocities. So the higher the energy, the faster the molecules are moving, and the more collisions between those particles. All right. So again, if the dotted line represents the activation energy, then as the temperature increases, so does the fraction of molecules that can overcome the activation energy barrier. The more molecules that can overcome the activation energy barrier, the faster the rate of the reaction.